knowledge. So, you know what is a knowledge? It is nothing but the facts or information or the real world facts. So, this is about a knowledge. It consists of precisely defined syntax and semantics which supports the sound inference. So it's going to support with the syntax and semantics. It applies logical rules to the KB to deduce new information. So to deduce means to derive. Dear students, welcome to computer science classes. I am Ravi Kumar KR, lecturer in computer science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Student, let us start discussion with that is Unit 3 and Session 1. The Unit 3 is Knowledge Representation in AI. That is the chapter. Now, in this session, we are going to talk about knowledge-based agent. This is the topics to be covered in this session. Now, let us see what is knowledge representation and reasoning. It is a KR, knowledge representation, and KRR stands for knowledge representation and reasoning. So let us see what is it. So here it is a part of AI system. Then knowledge representation is a part of AI system. We're concerned with AI agents thinking and how thinking contributes to intelligent behavior of an agent. So here we are representing the thinking capacity of AI and how we are going to convert this as an intelligent behavior, or how we are going to implement the thinking capability of a machine, of AI system or an agent. So here it is responsible for representing information about the real world so that computer can understand and can utilize this knowledge to solve the complex real world problem. So the main concept of knowledge representation and reasoning is, so it is for representing the information, the real facts, whatever the facts, into the through computer, and we are going to utilize the computer knowledge. It is responsible for representing the information about the real world. So here how it is possible? Here computer can understand and can utilize the knowledge. So the system, computer system can utilize the knowledge available in the knowledge base or in the through the knowledge based agents. So, and it enables the machine to learn from the knowledge and experience, behave intellectually. So that is the main purpose of artificial intelligence. So through this, through representing the knowledge representation, through representing the knowledge with the help of reasoning or logical thinking, you have to make it enables a machine to learn from the knowledge base and experience, and it has to behave intellectually how the human beings we behave. So that is the main concept of AI system. So that is the main aim of knowledge representation, means representation of knowledge and into the computer system, so that computer system or any device, any machine, it behave intellectually. Now look at the example here, diagnosing a medical condition. This is the application of AI system, and communicating with humans in natural language. So these are the applications or examples where the machines behave intellectually. Now let us see the different terminologies here. One is knowledge. So, you know what is a knowledge? It is nothing but the facts or information or the real world facts. So, this is about a knowledge. And how do we get the knowledge, or we gain the knowledge from reading, listening and experience. So what is what is the knowledge? So you take an example like human beings, we are getting so many knowledge from different applications or different methods of how do we gain the knowledge, by reading a book or reading, by listening, or from my experience we are learning the knowledge. You take simple example where if we touch any hot object once first time, we feel that immediately we take out our hand from that object. Suppose anytime next time we'll avoid touching any hot objects because that's the knowledge we have learned from our experience. Similarly, same thing, same concept has to be implemented with the system. So we have to gain the knowledge in this way. The computer system has to gain the knowledge from the facts, information from the experience. Next definition is thinking ability or analyzing the situations. It is, if you, with respect to programming concept, we can say if, then, or if not. Or this is logical thinking. If not A, if it is B. If not B, it can be A. That is a logical thinking. So this is one of the reasoning, that is the heading is knowledge representation and reasoning. This is a concept of reasoning, that is thinking capacity. Next one is intelligent. What is an intelligent? So apply the skills, knowledge into action. That is nothing but intelligent, or implementation of knowledge. So what is the intelligent? So here, whatever the knowledge we have gained from the experience or from the real world or from the facts, that has to be implemented through the skills. That is nothing but intelligent. So here, representation of knowledge with a reasoning power, it leads to an intelligent behavior. So same thing has to be applied to a computer system. So we should behave intellectually with the help of the knowledge and reasoning. That is the concept of knowledge representation and reasoning. In the next slide, we will see knowledge-based agent. Now you know what are agents in AI system. AI system, the main component is agent. Agent is the main component of AI system. So here we are going to learn one type of agent, that is knowledge-based agents. Knowledge-based agent. So let us see the definition of this. So here, knowledge-based agents are those agents who have the capability of maintaining an internal state of the knowledge, reason over that knowledge, and update their knowledge after observation and take actions. These agents can represent the world with some formal representation and act intellectually. So what is the definition of knowledge-based agent? This is a type of agent, and they will be maintaining an internal state of the knowledge. They will be having the information about the knowledge, and reason over the knowledge means the reason for the particular knowledge, as well as updating their knowledge for the future application. So these are the things has to be done inside the knowledge-based agents. So this is the main concept of knowledge-based agents, or KBA. Actually, this KBA we represent like this. It is composed of, there are two main parts of KBA. One is knowledge base, second one is inference system. There are two components of knowledge-based agents. Now look at the diagram, schematic diagram of knowledge-based agents. So if you look into that, this is the environment, this is input from the environment, this agent perceives the environment. So here, if you look into that, we have seen there are two components. One is inference engine, knowledge base, and learning or updating knowledge. KB stands for knowledge base, KBA is knowledge base agent. So this is the schematic diagram of KBA, or knowledge base agent. So let us see the different functions of different components, or how KBA functions. In the next slide, we will see the architecture, or what are the different components of this. So it takes the input from the environment by perceiving the environment. That is the basic function of any agent in AI system. It perceives the environment, means it takes the input from the environment. So here, as we have seen, one of the components is called knowledge base. What you have seen here this is called knowledge base. So what is knowledge base? It is the central component of a knowledge-based agent. It is also known as KB. So this is the place where it stores different types of knowledge about what we have seen in the previous slide. It is the facts, about information, about with the help of reasoning, everything with logical thinking, all the informations will be stored in a component called KB. So it is a collection of sentences, stores fact about the world. It is a fact. It required updating knowledge for an agent to learn with the experience and take action as per the knowledge. And what you have seen in the previous slide, one of the components called learning, that is updating KB. So this knowledge base has to be keep updating regularly because with the previous experience. So it is going to have the information about the experience, current experience or the previous experience. So it is going to use it for further or for future examples. So that is learning here. So it has to be keep updating. Now the input taken by the inference system or engine of the agent and which also communicate with KB to decide as per the knowledge stored in the KB. So here we have seen one of the component is inference system. It is what is inference engine or a system is going to perceive the environment, takes the input from the environment, and the input has to be passed on to the knowledge base, and it has to be sent to knowledge base for different actions available in the stored in the knowledge base. So based on that, it's going to select the whatever the knowledge base has been selected from the knowledge base, it is going to implement through the inference engine and it is going to generate the output. So that is the function of inference engine. So here it applies logical rules to the KB to deduce new information. So to deduce means to derive. To derive a solution to any different problem, it has to make use of different logical rules. The learning element of KBA regularly updates the KB by learning new knowledge. That is what the one of the component, learning component of ABA. The main function is it has to keep updating the knowledge or knowledge base with the experience of the previous values, previous data or different types of information. So this is the different components of KBA. In the next slide we will see, and the agent, the KBA can do the following function. It should be able to represent the status, actions, etc. An agent should be able to incorporate new percepts. It has to accept the input from the environment and update the internal representation of the words, that is updation of KB knowledge base, and deduce the internal representation of the word, means it has to derive at the new solution and it deduce the appropriate action. So it has to come to it has to select the right action for depending upon the perceived, depending upon the input perceived from the environment. These are the functions of KBA. And this following are the three functions performed by KBA. One is tell function, as function and perform function. The tell operation tells the knowledge base what it perceives from the environment. So here whatever the input is received from the environment, it has to be sent to knowledge base through tell function. Then what is as function? This operation as the knowledge base what action it should perform. So it is knowledge base is going to select the best action based on the previous experience or based on the facts available in the knowledge base, and it has to be conveyed through as function. Next, perform function. It performs the selected action. KBA perform the selected action selected through knowledge base. These are the different functions of KBA. In the next slide, we will see logical representation. So next concept is logical representation. So it is one of the techniques of knowledge representation. So in the previous slide we have seen the heading as knowledge representation. So one of the method is logical representation. So what is it? It is a language with some concrete rule which deal with the prepositions and no ambiguity in representation. So logical representation, it can be done through prepositions. Now what are the prepositions? These are the statements or a sentence which has two possible answers, either yes or no. Those type of functions, statements, sentences are called as prepositions. So for example, if I ask you a question, how are you? You can say, I'm fine. That is not a type of answer we expect. Those type of are not example for prepositions. Just if I ask you a question, have you had your breakfast? Then your answer will be either yes or no. So if for any sentence with the possible answers either yes or no or true or false are called as prepositions. It consists of precisely defined syntax and semantics which supports the sound inference. So it's going to support with the syntax and semantics. Each sentence can be translated into logicals using syntax and semantics. We are going to convert the statement into logical statements. And syntax is well-formed sentence in the language. Semantics is the truth or meaning of the sentence in the word. So what is the definition of syntax? Syntax is nothing but the well-formed sentence, and semantics the truth or meaning of the sentence. Now this logical representation can be explained with the help of propositional logic and first order predicate logic. These are the two different types of logic which can be expressed or represent. The knowledge representation can be done through logical representation. In the next slide, we will see what are propositional logic. What are propositional logic? So I have told you just now, what are propositional logic? It is a very simple logic, and any propositions, as I told you just now, it can be a type of sentence, a statement. Possibly it would be having answers either yes or no or true or false or 1 or 0. Those type of statements are nothing but propositions, and it is nothing but a declarative statement with either true or false. It cannot predict, it cannot assume. And propositional logic is also called as Boolean logic. It works on zeros and 1. Just what I told you about, we represent true as 1 and false as 0, yes or no. It is based on the Boolean. It is also a part of Boolean algebra, what you might have learned in your junior classes. So this is 0 and 1 are the values to represent either true or false. And it consists of an object and relations or functions and logical connectivity. So these are the concept here. There are three components here. One is the object, and next one is connectors or connectivity. Second one is the function. And these are called as logical operators. So these are nothing but logical operators. It means it's going to work or operate on different types of propositions. Now look at the example now. It is a Sunday. It is Sunday. It is a simple statement. It is a simple proposition. It is an example for proposition. In the next slide, there are two types of proposition. One is atomic propositions. Second one is compound propositions. There are two types of proposition. So what are atomic propositions? The definition is that it is simple propositions, and it consists of a single proposition symbol, and these are sentences which must be either true or false. This is what I told you just now. Atomic propositions are nothing but a statement which would be the possible answer would be either true or false. Look at example. 2 plus 2 is 4. See, it is an atomic proposition. It is a true fact. It is a true. 2 plus 2 is true. 4, it is a true. It is an atomic proposition. Next, what is compound proposition? So it constructed by combining simple atomic proposition using parentheses and logical connectivity. As we have seen in the previous slide about the logical connectivity, so we are going to combine, we are going to join atomic propositions to form compound proposition. For example, it is raining today. and street is wet. So if you consider this, so this is one atomic proposition. So this is street is wet is another atomic proposition, and we are combining these two with the help of logical connectivity. So this is the definition of compound proposition. Now let us see the different operations or logical operations, logical operators which are available or which can be performed on atomic propositions. Now this is the symbols and the meaning and technical term as well as example. One is this connectivity symbol, this is called AND. This is logical AND, conjunction A, conjunction B. Similarly OR is, look at a symbol, invert V. So this is disjunction A, disjunction B. So it is implies, implication, operation called implication. A implies B. Next, this is called bidirectional, if and only if. It is called as a function is biconditional. Biconditional means if and only if. And this is negation. It is negation or not operator, or this is wave symbol or tilde. This we are using for to represent not operation. These are the different connectivities, or you say connectives or logical operator to connect simple propositions. In the next slide we will see what is truth table. So in a propositional logic we need to know the truth values of propositions in all possible scenario, all possible combinations. So we can combine all possible combinations with logical connectivities, and representation of these combination in a tabular form is called as truth table. So this is a definition of truth table. What is a truth table? It is a tabular format. It is in the form of table, and the table consists of what? It consists of all possible combinations along with the logical connectivity, along with the values. So this is nothing but the truth table. In the next slide we will see the truth table for different logical connectivities. So first one is for negation. This is for not operation. So consider only variable, that is P. P is one proposition. If there are one proposition, so there are two possible values, either true or false. Either you can represent with the values 1 or 0. So here, suppose P is true, obviously this negation not P, this symbol is not P is false. That is inverse of P. So inverse of true. True is, if it is true, not P is false. Suppose P is false, this is true. This is a truth table for negation or for not operation. Next one for conjunction. So this is the conjunction. There are two propositions, P and Q are two propositions, and P conjunction Q. These are the function. So this is the operation. So here there are two propositions and there are four possible combinations. So look into that. Either this is true or true, it is one combination. True, false, false, true, or false, false. These are the four combinations of for these two propositions P and Q. And the operation is what? So here, true, true, the result is true, or the function, or the result of the function is true, and this is true and false, false, false and true, false, and false and false, false. So this is true. So it is when both the propositions are true, then the conjunction will be true. That is the definition of this conjunction operation. If any of the values are 0 or it is false, the result would be false. This is the truth table for conjunction operation. In the next slide, we will see what are disjunction. So here again two propositions P and Q, and there are four possible combinations: true, true, false, true, true, false, and false, false. The output would be true and true, it is true, and false and true, true, true and false, that is true, false and false, it is false. So if you look at this, the result or the output of this operation here, if any of the proposition is result is true, then the result would be true. That is the definition of this. So if you consider these three combinations, one of them will be true, result will be true. But if you look at the fourth combination, it is false, false and false. So this is the definition of disjunction operation. Students, so far in this session, we have learned the definition of what is knowledge, knowledge base and knowledge representation and reasoning. And also we have learned about KBA, knowledge based reagents, with the components and the functions, how it works. And also we have learned the propositional logic, and under that we have learned the different types of propositional, that is atomic proposition and compound propositions and different logical connectivity. So let us continue our discussion in my next session. Thank you so much.